I want to add a new type of movement to moving entity, because right now in our subclass sandbox, we only offer our children one possible way of moving randomly. So I want to add a new type of movement. It's going to be called move toward world coordinates. And we're going to give it a target X and a target Y. That's what the TXTY means. Target X, target Y. So the idea is, wherever we are, we're going to move in the direction of target X, target Y. So move in the direction of target X and target Y. Target X coordinate and target Y coordinate. Alright, so how are we going to do this? Let's talk math. Let's say these are the XY coordinates where we are, and these are the XY coordinates that we want to move towards. We need to figure out what is this direction. So here's a nice way to do it. Let's imagine this is a right triangle. I'm going to call this delta X. I'm going to call this delta Y, because that's like the difference in X and the difference in Y. Delta X is Tx minus X. Delta Y is Ty minus Y. So, basic trigonometry tells us that the tangent of this angle is delta Y over delta X. So I can find theta as the arctan, which is the inverse tangent of delta Y over delta X. Alright, so once I've got my theta, if I want to, I can figure out, like, if this is a unit vector pointing in this direction. A unit vector is just a length 1 vector pointing. I can figure out what's this and what's that by using sine and cosine. So my x component is going to be cosine of theta. And then if I want to be traveling at a certain speed in this direction, all I need to do is scale this vector by whatever my speed is. So I would multiply this by speed. And then same thing, y component is going to be sine of theta, but then again I'm going to scale it by my speed. So that's all the math that's necessary in order to send us in a particular direction. So let's implement it. Alright, so what am I going to do? I'm going to make a helper method called getAngle toward txty. Where'd I create it? Here we go. Alright, so getAngle toward, I'm going to do what I said. So delta x is going to be tx minus my own x coordinate. dy is ty minus my own y coordinate. By the way, t stands for target, d stands for delta. Alright, and so now I'm going to return math.arctangent. Let me just look at how arctangent looks. So it looks like A is my angle. No, that doesn't make sense. A must be the ratio. Okay, so it's going to be dy divided by dx. And so that should return the angle. Alright, so now that I've got my angle, I'm going to set my x speed to be equal to speed times the cosine of the angle, and my y speed to be speed times the sine of my angle. Oops. And I gotta cast them to int. Cast it to int. And now what? I guess I'm not actually moving yet, so now I've got to update coordinates. And remember, update coordinates will take my x and my y speed and it will change my xy coordinates. Alright, so I think this should be working. I'm going to go ahead and change how my wumpuses move. So instead of moving randomly, I'm going to say this dot move toward world coordinates. I'm going to move towards world coordinates 1000, 1000. So all of the wumpuses are going to congregate in one spot. Alright, let's see what it looks like. Oh, it's like they all moved too fast. I didn't get to see it. Let's try again. Okay, what if we make them all move towards 1010? That will be like right on top of me. It looks like they're all running away from 1010. Okay, here I am fixing it because I don't remember the difference between ATAN and ATAN2, so I'm here in the API, and it says arctangent returns the arctangent of a value. The returned angle is in the range -pi/2 to pi/2. Arctan2 says it returns the angle theta from the conversion of rectangular coordinates to polar coordinates, and that is exactly what we're trying to do. So let's change it to be arctan2. So here, math.arctan2, dy dx. And now let's see what it looks like. Cool, so now it looks like all the wumpuses are running right here to 1010 on top of each other, except for the ones who got stopped by the mountains. Alright, let's add a slightly modified version of this where we can have them run toward another entity. So here in moving entity, we've got move toward world coordinates. Let's add move toward entity, and we take an entity as an input. Well, this is easy enough. If we want to move towards an entity, we just need to know what world coordinates is that entity at. And then we'll run move toward world coordinates, but for that entity's get x and get y. Instead of the get x, get y, I'm going to use the center x and center y, because we want to run towards the center of another entity. So that was very, very fast. So move toward another entity. And now let's go ahead and have our wumpuses. Let's have our wumpuses move toward the player, maybe. So the wumpus is going to move toward entity. I want to have them move toward the player. Okay, but we don't have a copy of the player here. So what I'm going to do is, whenever we construct wumpuses, or let's do this. Let's construct wumpuses with a target. So private entity target. And so now this dot target equals target. So when we construct a wumpus, we give it a target, and then we have the wumpus move towards its own target. Alright, so now where we're constructing the wumpus, we got to give it a target. I think we have access to a player in here. Is that true? Nope, we don't. Level dot. I could have sworn we had a player in the level. Where are you? Level. We do. Maybe something else is going wrong. Oh, we got to cast player. Oh, I'm sorry. Our player isn't an entity. I totally forgot. Okay, well, that's unfortunate. Alright, well, we'll deal with this next time. I think we've done what we've wanted to do.